Hello, welcome back to our tutorial series on basic electronics, and this time I am going to talk with you about junction field effect transistor. So let me write. So in short form, it is called as junction field effect transistor JFET, or simply you can also call it FET, field effect transistor. So as the name suggests, there is an electric field which controls the conduction through this transistor. And just like bipolar junction transistor, there are two types of FETs or field effect transistor. One is called as N-Channel FET or JFET, and another is P-Channel FET or JFET. So if we want to draw the symbol, for example, for the N channel and the P channel, it would be like this. And when you draw the symbols, you see that it is a three-terminal device. So the terminal is called drain, this is gate, and this is source. And the direction of arrow indicates whether it is N channel or P channel. So if the arrow is pointing inside the gate, it is N channel. However, if you have a symbol with the arrow pointing outwards the gate terminal, it is P channel FET. So these are the two types of transistor. Now, let us understand the direction of the currents flowing through these transistors. So before that, the voltage at the drain is called as drain voltage VD. The voltage at the gate is called as gate voltage VG. The voltage at the source is called as source voltage VS. And the direction of the current through the drain is ID. Current through the source terminal is called IS, and current through the gate is called as IG gate current. Similarly, here the voltages are VD, VS, and VG. The direction of the current or the gate current is like this. The current which is flowing through the drain terminal is like this, and this is the current through the source. Similarly, we can indicate the potential drops or voltage drops across the three terminals of the N channel and the P channel FETs. So here gate is negative with respect to drain, and the voltage is called as VGD, that is voltage between gate and the drain terminal. Here the drop across is between drain and source is referred as VDS, and here again the gate is negative with respect to source, and that voltage is called as voltage between gate to source VGS. Similarly, here gate is positive with respect to drain, and the voltage is VGD. We call it same as this voltage, but see the polarity is reversed. Similarly, gate is positive with respect to source, and you refer to this voltage as VGS. And here the drain is negative with respect to source, or source is positive with respect to drain, and call this voltage as VDS. Now, if you see the polarity for the voltages in N-channel and the P-channel are just reverse. You have negative and positive here. You have positive and negative. Then you have VGS negative. Here VGS is positive. Here VDS is positive, and here VDS is negative. So whatever the polarity you have for N-channel, just change them and reverse them for the polarities in the P-channel. Now, there are some terms we would like to define here. For example, IG is the current. Let me draw it. IG is approximately 0 volt. It means gate to source reverse biased for the normal operation. If you want to make the FET work in a normal region, normal operation, your gate to source voltage is reverse biased. And in that case, the IG is equal. IG is the gate current at the 0 voltage of the VGS, gate to source voltage. Now you say ID is equal to IS. This is your drain current is equal to the source current. Then you write ID is equal to 2IDSS divided by VP square in bracket VGS minus VP minus VDS divided by 2, multiplied it with the VDS. This is the expression for the drain current in linear region. So remember your characteristics, your IDS versus VDS for the values of VGS. These are the characteristics as for VGS1, VGS2, right? And here, this is a linear region of operation. This is a linear region of operation, and the rest here is the saturation region of operation where the current is saturated. So you can say that this is an expression for the drain current in the linear region. Okay. Now let me write an expression of the drain current in the saturation region. Okay. So here we can write ID is equal to IDSS in bracket 1 minus VGS divided by VP whole square. So this is a drain current in saturation region. So what is IDSS? IDSS here, a saturation current at 0 gate to source voltage, VGS equal to 0. This is the current, saturation current when VGS is equal to 0. What is VP here? VP is the pinch of voltage. Pinch of voltage where the drain to source current stops. Where the drain to source current, that is IDS, is equal to 0. Is not equal to 0, rather we will say where the IDS stops. So you see, your current is increasing here. Let me draw it with the red pen or some other color. Your current is increasing and then it saturates. So this is the pinch of voltage where your current no longer increases. All right. And that's it. So it's about all terminals and symbols of the FETs and the current and voltages. And the two currents, that is the drain current in the linear region and the drain current in the saturation region. We have seen that. And you can see that these are the expressions which are very important in understanding the behavior and the operation of your junction FETs. Okay. So hope you liked this video. If you did so, share it with others for wider reach and stay tuned for more informative contents like this. Wish you happy learning.